Hi and welcome to today's video, and I'm rather excited to show you my feat. I'm rather excited to show you these two machines which I recently acquired. Now we have one of the earliest Betamax machines, or rather Betamax models, available for the UK market, the Sanyo VTC 9300, and it also comes complete with this operating card, which is quite cool. Unfortunately, the previous owner couldn't find the remote control, but to be honest with you, little things like that don't generally tend to bother me. So long as the machine is working, or even then that doesn't bother me that much, so long as the machine has been stored in a reasonable area and not stored in a damp shed, then you're pretty much guaranteed to have something that will need minor work to get it to function correctly. We do have this rather nice little card which tells you how to use the machine, so it's sort of like a quick reference card, which is really cool. The other machine that we have is rather special, and it's one of the, I guess you could call it one of the UK market dream machines. It is the Sony SLC9UB. It is arguably Sony's first linear stereo Betamax deck. It comes with its box, which is quite frankly incredible. This box is nearly 40 years old now, but because it's been stored in a dark area, it's still in remarkable condition, which, seeing it's by the window at the moment, I will have to move it after I finish the video. Probably put it down under here with the other bits and pieces. But in there we do have a C9. It comes with a remote control, and it also comes with a user manual as well. Now what we're going to do first is we're actually going to be focusing on the 9300, and then in the next video we're going to take a look at the C9. So before we do anything, let's get the lid off and let's see what we're dealing with inside. So we have, looking at it, we have several screws that we need to undo. And we'll be starting with the top side, and then we'll be moving underneath to have a look at the condition of the belts. So the year this machine was produced is approximately 1978-79. Sony's equivalent model is the SL8000. Later versions of that model were badged as the SL8080. They both have very similar features, and they both operate in pretty much a very similar way, to be honest with you. Cover comes off like that, and inside it is, as you would expect, but there is an awful lot of space in there, and a huge motor which directly powers the head drum. But this huge motor has an enormous fan on top of it. If you actually look down below, can't really see it from here, but if you've got the machine upside down, there's actually another fan on the bottom. So the whole unit is cooled when in operation. So in other words, when it's in playback mode, the whole unit is cooled by the two fans here and underneath. So you've arguably got quite a lot of airflow through the unit, and given its enormous size, that actually works out quite well, so it probably runs very cool in operation. Power supply wise, we've got this board here, and we've got, looks like direct supply here for this motor, which is quite interesting. That's screwed down, but there doesn't appear to be any reefers on there that could explode, so that rules out something that we need to do immediately. There is an inline fuse, and that inline fuse looks like it's absolutely fine. Quick visual inspection, that is looking okay. And what we will do now is I will just flip the whole unit over and we'll take a look at underneath and see if there's anything that we need to worry about underneath. It weighs in at approximately 19 kilograms. That is a screw that I think I dropped in it previously, so we can use this opportunity to get that out actually. These feet are screwed in. They don't actually make up part of the case itself, so very reminiscent of the C7 and C5. We have this large metal panel underneath and 4 screws holding that in place. And keep those separate from the other ones as they are different to the other screws in the deck, or certainly the screws for the top lid, that is. There we go. And just take the bottom off. There we go. And like a lot of decks of this era, you've got obviously this very large board here, and we should be able to determine what this board is actually doing. You can tell it's for the PAL market because it says PAL, obviously. It also hinges up, as you can tell from the back here, so this will hinge up out of the way. There's going to be a couple of points where it's probably secured. Here, here, I would guess here as well. It's also secured to this rail down the bottom there. This is probably all of the audio and picture processing, I guess. I need to get hold of a service manual. EE level, yep, electronic to electronic. And interestingly, the whole board is really very, it's not clustered together, it's actually sort of very nicely laid out. There's that huge fan I was on about. So that's going to hinge up that way. So what I'll do is I'll turn the machine around. It's alright, sorry, I'm just looking at this panel. There's this other panel on the back that will come off. Which we can do in a minute, and that actually exposes what looks like the power distribution board and more fuses, so that's also worth a check up in a minute as well. So I'll just whip this around and around we go. Oh. Now, I need to undo the screws mounted onto this front plate. There. And here. Might do that one by hand actually. There we go. There's also going to be one here. And that is it. That's all you need. Now we get to look inside, and that has to be the most insane belt arrangement I have ever seen. That is ridiculous. So you've got, this looks like one motor powering everything. I think this is the capstan. This is the base of the head drum. And amazingly, all of these belts seem to be in pretty good shape. So I don't think I need to do anything about replacing these belts. So it looks like this board here with the large capacitors is one of the other power supply boards. There's a power distribution board there, I think. We'll take a look at that in a second. This board looks like it is image processing, judging by the fact that we've got a number of potentiometers on it. It's probably also doing audio as well. There's a delay line. Let me just have a look at the presets that are on there. I should be able to tell exactly what it's doing. So AFC, pilot burst, yeah, that's picture, still chroma, picture, so that's still colour. Then there is C-rec current, EE level, PB level, D-mod. Yeah, so it looks like it's dealing with playback and recording. And interestingly, there's a lot more Sony ICs in this than later Sanyo decks. So this seems to be a lot more Sony based than later decks, which is quite interesting to note. The condition of this deck though is absolutely incredible. It's in such good shape. I'm just astonished these belts seem to be in such good condition. That's what really surprises me, to be honest. Also, this is unusual. It looks like you've got the motor here, but there's another motor under the capstan. At least I think it's the capstan. So I'm wondering if there is a motor that drives everything, and then you've got another motor that helps to balance out the capstan speed. And there's a little brush there for removing static electricity, I guess. I'm just astounded at just how clean it is in here. So we're going to put this back down. I don't think there is anything that we need to do in there at the moment. One thing that I do want to do is to get that rear panel off and have a quick look at the condition of the capacitors. Check that none of them have leaked or anything of that sort of nature. So from what I have read, these machines just seem to have a reputation of just working. So we may actually have a machine that will potentially just turn on and work. I have powered it on already, but I haven't tested a tape or anything. It does come out of standby, but I haven't put a tape or anything in there yet to test it fully. The condition of it is superb though. I mean, it's in really good shape under there. We'll put the metal base back on so we can protect that circuit board. There we go. We've got our 4 quite fat screws to go in there. It is interesting to note, just as I keep saying, just the amount of space in there. I also like the fact that there's a fan in there. It'll probably make it very loud in operation, but it does mean that all of the electricals inside can maintain a pretty steady temperature when under load. Sony C5s C6s and C7s had a similar feature because they had this sort of quite large fan on top of the video head, and when that was in operation, sort of on the top of the machine, you had basically a vent, and under that was the little fan for the head. When it's in operation, you could feel a certain amount of sort of air coming out of there, so that actually drew air through the machine as well and kept things running quite cool when that was working. Right, onto this back cover. Have this rather cool little RF converter cover. So, like the JVC HR 7700, it appears that you've got a plug-in RF module, which is rather nifty. That means that you can easily swap it for different markets. That's rather cool, actually. Now, let's have a look at what's going on behind here. You have these, which are the video in, video out. I forget the name of these, but you can get a converter that converts it down to BNC, and then another converter to convert it to phono. They are a professional grade connector, though. They use them a lot in CB radio, from what I recall. And off that comes. Just move that out the way. Pop that over, way over there for the moment. So we have this little power distribution board here, and fuses look okay, capacitors look alright, but let's try something. Now I should really test these out of circuit, but I'm going to see if my newer tester will be able to just focus on the capacitor rather than anything else in there. They're Sanyo badged capacitors, so make of that what you will. Making sure there's nothing else keeping it in place. Don't think there is, there shouldn't be. Whoops. Right, so no, there is definitely nothing else holding that in place, I don't think. It doesn't seem to be clipped in anywhere. So that should just come out, although it doesn't seem to want to. It's okay. Let's undo this screw. Let's move this out the way. And I've just found that screw that I lost. There we go, that's back. There we go, that moves that out the way, but that doesn't help me in any way. Where is it still holding on? Let's move this out the way. So does that give me an inkling into what's going on? No, not really, although yes it does, because there is a little plastic pin underneath here, and that appears to be what's holding it in place. And looking at it, yeah, I can see that now. Looks like it actually goes sort of upwards. I'm not certain how that would work. So I'll just put that back in place a second. Let's see if I can flatten it down a bit and pull the board forward. Light bit of pressure. You don't want to snap it at all. And then just try and work that through. So I'll need a little screwdriver, flat blade. There we go. So a little flat blade. Whilst applying light pressure, just need to pop that down, that up. There. That has worked, but it's still held in somewhere else. And I wonder if it's because we've got so many wires on there that it is just literally inaccessible easily. So I'm just seeing if there is one of those, another of those, oh look, there's a connector there. What's that for? Oh, it's a heatsink. Oh, okay. That's why it won't shift. There's a heatsink on here. And to get to it, might be able to get to it through that side panel. So there's another side panel. Follows a very similar structure with these panels to the original original Sanyo, the original JVC VHS decks. It seems to follow sort of a very similar construction method. And then if you look through here, see if I can focus in. There you go, there's the screws that hold in that transistor to its heatsink area mounting. So what I should be able to do is going in here, just undo both of those, and that will allow me to pull this out. There's one. And there is another one. Did I need to remove that one actually? No, I didn't. That one can go back in. So I can remove that one when we're out, because that one is what holds the transistor to the heatsink panel. And you've got one down the bottom that holds the rest of the panel to this bracket. And after a short time, there we go. And that is now, that's a lot more accessible than it was. Still got, there's a capacitor over here, so I'll take that off as that just sits on the side. And I need to just take care that I don't touch the terminals on that capacitor, because it might still be holding charge. And there you go. And then I can collect both the screws. There should be one in here as well. And there we are. Now we can focus on this board. So we've got the board where we want it now. I've also realised that we don't necessarily need to have these two screws undone. So what we can do, whilst this is out, So there is what looks like a little plastic shield behind. We can put these back in place. There we go. Oh. There we are. There we are. There we go. Right, so let's have a look. This large capacitor is Rubicon 25 volts at 10,000 microfarads. That's a lot. That does look like a really big fat ballast of some description. Let's see if I can find my newer ESR reading item. There it is. Ow. There we go. Right, let's have a look. So, I think I am almost there. Right, so let me just pause this and read the instructions. Right then, here we go. So, if I take these off the probes. I don't even know if that's working. Let's have another look. Oh, you need to press release first. There we go. Then measure it. Right, what does OL mean? That's the next question. Oh, I might need to do large capacitance measurements, so that's probably over limit. So oops, it needs to go into here, here, and there. Okay, OL suggests that it might be open circuit, which is possible, I guess. Let's try another tester on it and see if that yields any different results. Uh, 10.47 microfarads, ESR 0.34 ohms, 10.47 microfarads. That might be right, actually. 10.47 MF. Let's have a look. That one might be okay. Let's try some of these other ones. So, let's pick on this one, which is this big middle one. Uh, 470 microfarads at 35 volts. This one's got too much interference from the rest of the board. 0.39 ohms, ESR, 490.2 microfarads, and it should be 470. That one's actually okay. So we've got 220 now. 0.29% ESR. That's probably measuring a bit high capacitance wise. That might be because I slipped when taking the reading, so let's do that again. Yeah, I think it's probably okay. I would hazard a guess that they're all probably alright, to be honest with you. Right, final thing that I will do. Let's put a new bit of thermal grease on there. There we go. There we go. Now we just need to visual check of these fuses. They all look absolutely fine, so if they're checking out, I'll put this back in. There's no visual leaks from these capacitors, and they do seem to be giving me some kind of feedback, so that's something. There we go. Now we just need to pop it back in at the side. So I have to go through here, and we'll start off at the top. Take my glasses off these, I need to do the work close up. There we go, that's one, that's the top one. And put the bottom one in. Bottom one ain't so easy because it's harder to see. If I come around this side, yeah, that's better. There we are, that's the bottom one in. Let's put this one back. That's our big ballast capacitor. Voltage wise is not that high, but you might get a kick out of it because of the amount of farads that's in there. Either way, I wouldn't want to touch it, despite the low voltage. There we go. Right, final thing I want to do is I could probably check these two diodes. They should be flowing that way, I think, looking at the arrows on them. So we'll use my little machine to do that. And diode continuity check. That is on 17. So I need to be up to here and here, and switch it to diode mode, which is, funny enough, the first mode actually. They're fine. Absolutely fine. I think there's a couple behind here. Oops. I think that was okay. I just slipped off. That's fine. Ooh, another diode. Also fine. Right. That almost concludes our visual check. So we have done a visual check on the capacitors on that board. We've tested them as far as we can, definitely getting inaccurate results, because you don't really get accurate results unless you test out of circuit. But they seem to be okay. I will probably start putting this back together. There we are. There we go. Now, a lot of places say that these particular decks are of only real interest to collectors because they are so huge, antiquated, and low on features. But that also makes them, by comparison to a lot of newer stuff, also very simple, very easy to troubleshoot. Well, relatively easy to troubleshoot. And I'll be honest, I think I can easily find a home for it in my collection. That is, so long as it works. Otherwise we'll just have a very large, relatively handsome paperweight. Right, there we go. Do I want to do anything on this board? No, that is, looking at this, due adjustment, rewind, sensor adjust forward. There's a processor there. I think that is one of the deck control boards, so don't need to worry about that. It's mainly the power supply board I'm interested in, just to make sure that it's not going to blow up when you hit play for the first time, and that any electronics that are in there aren't going to get unduly stressed. That certainly looks like it's not going to be the case, to be honest with you. Thankfully it seems to use these screws across the whole lot. And also another bonus bit is that board was behind that ventilation panel, which is pretty handy. Let's get all of this buttoned back up. There we are. Oh, let's put that side panel back on. That's nice. Slide panel just slides on, which is quite nice. Nothing really too drastic about that. There we go, there's one. And there's the other. Right, let's grab a cloth just to give everything a bit of a clean. So I'm not going to touch the actual heads themselves yet. I just want to generally give this just a light dusting, because that seems to be all it has in here is just dust. Right, let's turn it around, hook up some power and put a tape in. That's a good sign. Comes out of standby. Grab a test cassette. That's familiar. Probably slow slippage of the belts. Let's see if it fast forwards. So no rewind, that's probably belt slippage. That's interesting, that capstan isn't engaging, the pinch roller rather, so there's the pinch roller. That should engage up against the capstan there. So it ejects, which is good. And it looks like there should be some more movement on that to get that to engage. So one of the first things I'm going to do, I didn't think those belts needed replacing, but do you know what? I think it would be a good idea to replace them. There does seem to be belts available on eBay, so I'm going to get a belt kit, and then we can revisit this one at another point in the very near future. But as you can see, nothing has blown up. We certainly do seem to have something going on, which is quite cool. And I think now it's going to be a case of giving it a refurbish of the belts. That pinch roller is quite disgusting. Might be able to fake. Let's have a look. I might be able to fake something. But yeah, can certainly try something. Anyway, hope you enjoyed this video. If you have, don't forget to hit the like button, don't forget to subscribe, and I'll see you again soon. Thanks for watching.